Hello geometry students, and welcome to the lesson for 6.3. It can be found on these pages in your books. Really no new vocabulary to learn here. It's essentially going to be the converse of what we saw in 6.2. So I'm going to refer back to 6.2 a bit here. If we look back at, one more, there we go, we look back at this, we're going to be saying let's now assume that you're not starting with a quadrilateral, not starting with a parallelogram, sorry, and see if you can prove that it is actually a parallelogram. So you're going to have a quadrilateral to start. What can you use to help prove that it is actually a parallelogram? So let's draw in some pictures of parallelograms to start here first, and I'm just going to have that general slant off to the side. Let's write in our theorem numbers though before we get into that too much. So this is going to be 6, 6, 6, 7. These are going to be 6 different ways we can use to prove that different shapes, different quadrilaterals, special four-sided polygon or a four-sided polygon, we're going to use these 6 theorems, actually 5 theorems and 1 definition. We're going to use these 6 things though to be able to prove that different shapes are parallelograms. So we can use any of these 6 things. This last one is actually just the definition of a parallelogram. We're going to use any of these 6 things to help prove that these are actually parallelograms. So I'm going to draw in parallelogram right here. I'm going to make that a little thicker. I want to make that a little bigger too. There we go. And so this is going to be my general shape. This one happens to be leaning towards the right. They don't always have to be that way. Let's see if I can draw that a little neater. Yeah, that one's pretty good. Okay, so just take that general parallelogram and duplicate it 6 times. Okay, so make 6 parallelograms here. What makes something a parallelogram? So you'll notice that this is going to correspond very, very well with what we had here in theorem or in lesson 6.2. So theorem 6.2 said that if you had a parallelogram to start, then opposite sides were congruent. Now we're taking what is the converse of that. We're going to say if you have opposite sides congruent to start, then you have a parallelogram. So let's say that this was true. If that was the case, notice this is a quadrilateral. It's a four-sided polygon, four-sided shape. If these were true to start, it's actually a parallelogram as well. So this is one way to prove that a shape, a quadrilateral, is a parallelogram. So both pairs of opposite sides being congruent. That's one way to prove something. One valid way to prove something is a parallelogram. Alright, so theorem 6.7 goes with theorem 6.3. Opposite angles, if those are congruent to start, then you can assume that this shape, this quadrilateral, is a parallelogram. So both pairs of opposite angles being congruent. Another thing you can use is that if the angles are supplementary, consecutive angles. So we're going to say if you had any old angle, x, and then 180 minus x would be the supplement of that, because if you add x to 180 minus x, the x's cancel out, you're left with 180. For instance, if this was 50 degrees, this one would be 180 minus 50 would be 130. 130 plus 50 is 180. And so any consecutive angles that add to 180, if that's going to be the case for any pair of consecutive angles in a quadrilateral, then you know that shape has to be a parallelogram. So angle is supplementary. To both of its consecutive angles. If that is the case, then you know that shape, that quadrilateral, has to be more specifically a parallelogram. Alright, it's Theorem 6.9, going back to the diagonals again. If this is the case, if the diagonals bisect each other, then you know that shape has to be a parallelogram. And so this one, the diagonals bisect each other. Theorem 6.10. This one's a little new. So these four went right in order with these four. So nothing new here really. It's just the converse of these things now. Theorem 6.10 though builds a little bit upon what you have there. If you had one pair of parallel sides that was also congruent, then this would also have to be a parallelogram. You can prove that it's true, and they actually do prove it's true. Looking in your book here, they do prove it is true on page 340. If you really want to check that out, they have example 3 on page 340 is an actual proof of that, why it works out. But we're just going to take it and use it for our sake. So if you have one pair of opposite sides that is both parallel and congruent. So both congruent and parallel, I'll say it like that, congruent and parallel. If that's the case, then you would know that this is also a parallelogram, not just a quadrilateral. And the definition of a parallelogram says you have two pairs of opposite sides being parallel. So if that's the case as well, you also know you have a parallelogram. So both pairs of opposite sides are parallel. So I'm going to throw a few examples your way. Draw 3 pictures in this example, example 1, and let's see if we can determine whether these are actually parallelograms. So are these, I think it's a good thing to say necessarily, are these necessarily parallelograms? So that's my abbreviated way to write parallelograms, and if so, state why. So some of these might look like, I'm going to try to draw all these so they look like parallelograms, but some might not actually be parallelograms. So I'm going to draw 3 different examples within this one here. I'm going to split this up into 3 parts. And there we go. So let's draw in our parallelograms, our parallelogram looking shapes at least. Draw that in first. This one I'm going to put on a kind of a funky slant here, but nobody said I couldn't do that. There's no reason why I can't do that. I'm trying to draw all of them so they look like parallelograms though. So trying to draw opposite sides being parallel as best as possible. And then this one, I'm going to kind of draw a diamond looking shape, so it still would be a parallelogram if that opposite sides were parallel. It's almost looking like a square, but we're going to not say that these opposite sides are parallel right now. Even though they look like it, we're not saying that is true. But we are going to say these things. So I'm going to say in this one that this and this are the same, and then that and that are the same. In this one I'm going to tell you that this side's parallel to this side, and this one's parallel to this one. And then in this one, I'm going to say this is 60, and this is 120, and this is 60 degrees. So notice these aren't drawn to scale. This looks more like a 90-degree angle than 60, but you assume what's true as what's given to you in the picture, not what it looks like. So this one, are these necessarily parallelograms? This one I would say is a little bit harder to determine. So we're going to come back to this one. Let's deal with the easier one, the easiest one first here. This right here, that's the definition of a parallelogram. If you have two pairs of opposite sides being parallel, then you say, yeah, that's got to be a parallelogram. So this one is yes. If so, state why. So this one would be yes by the definition of a parallelogram. This one is also, I think, pretty easy because 120 plus 60, either way you go, is 180. So that consecutive angles are supplementary. That is this one right here, Theorem 6.8. An angle is supplementary to both of its consecutive angles. That's exactly what's going on right here. 120 supplementary with 60 and 60 here and here. So this one you would also say yes. You could say that's true by Theorem 6.8. So you could refer back to that. You could write out the reason that the angle is supplementary to both its consecutive angles. You could write it out as well. This one, well, let's see. So do we have a theorem that looks like this specifically? I know I have one pair of opposite angles congruent and one pair of opposite sides congruent. Is that enough to tell me that for sure that it's a parallelogram? So I have both pairs of opposite sides parallel would be enough. Both pairs of opposite angles would be enough. But is just one of each enough? I don't see that here. And so I'm going to say no. If you say no, it should be possible to draw a counterexample where this is actually still holding true, but you could draw a picture where it definitely does not seem to be or look like a parallelogram. And so if you were to draw, let's draw something in like this a second. Right, so I just paused it there so I could draw this and duplicate that and make sure it was precise. So notice this angle right here is the same as this angle right here. I just copied and pasted it, and I'm going to move that down here. And notice I did not change the length of this line either right here. So I'm going to move this around and I'm going to rotate it a little bit more. I'm not changing the length of the line. So if I do something like this, there we go. The way I just drew that, this is the same as this. This angle is the same as this one. And if I just extend these lines out a little bit more, these segments out here, here a little bit more, then I've successfully drawn a shape where this holds true. These things that had to be true at the beginning are still true right here. Nothing changed there, but I do not have a parallelogram. This is clearly not a parallelogram. So is this necessarily a parallelogram up here? No, it could be, but it doesn't have to be. And so with that, I'm just going to write down one more thing here, and I want you to write this down as well. To use example 4 on page 341, sorry, to help with any problems assigned in this range. So if I assign any of these problems from 21 through 26, check that out in your books on example 4, page 341. Use that to help you. We may go over something like that in class together, but for the sake of the notes, this is really the important stuff here, being able to understand these things. We're going to practice through a lot more of this together in class and then on your classwork and homework, but that should be a good start here for you. Should have a good solid understanding. If you understand these 6 things being what you need to be able to prove parallelograms, quadrilaterals are parallelograms, then you're off to a great start with this lesson. Alright, so let me know if you had any questions about that in class, and I hope the lesson goes well for you.